Okay, students, today we're going to be talking about Chapter 4 out of the code book, and this chapter is titled Foundations. Some of the things that I want to talk about in regard to this chapter are a little bit about concrete, a little bit about foundation sizes, and a little bit about rebar. And there might be a few things at the end that I want to add to that. But anyway, those are the main points that I would like to cover. As you read through this chapter, you're going to find a lot of information. Some of the things that I want to see that you have a good understanding with are, first, understanding a little bit about concrete materials. Now, this chapter also talks a little bit about alternative type foundations, footings and foundations, pressure treated wood foundations. I'm not going to really deal with that too much, simply because in this part of the country we don't really use treated lumber for foundations. Typically, pretty much everything that we're doing involves concrete to establish a footing and a foundation. When we think about concrete and using it as a building material, first of all, let's break down concrete and just talk about what it is. Concrete is a mixture of sand, gravel, cement, and that's the raw materials. And then to activate that mix, we add water. And the water activates the cement. The cement then there's a chemical reaction in which the cement begins to catalyze, and basically what happens is, over a relatively short period of time, the cement, sand, and gravel solidify into a hard mix. And the reason that we use cement, or not cement, but concrete for building, is that it's a great material to hold loads, to bear up the weight that we put on it. So we want to put it into a compressive loading situation. And quite often in building, that's what we do. We put the foundation down on a firm dirt surface, and that dirt surface potentially is going to bear whatever load transfer that concrete is going to transfer to it. Okay, so concrete is a simple compressive material that we use for loading. One thing you do need to know about concrete is that if you put it into a tensile application where you pull on it, it becomes a very weak material, susceptible to cracking and breaking. So, one of the things we do to compensate for that is that we add rebar. And rebar can be added into the mix. Typically, when we pour it, we'll put rebar into the footing and into the wall, tie it all together, so that when the concrete solidifies, it gives it an additional strength in the tensile or pulling load component. Also, it probably adds some strength in the compressive as well, but not typically as much. So concrete is the material that we use, and one of the things about concrete, depending on how it's mixed, it's going to have different characteristics. A certain percentage of sand, certain percentage of aggregate, certain percentage of cement. When those are combined in different percentages, we get different results. And one of the things that you need to know about concrete is that it comes in compressive strength mixtures. And years ago, we used to get concrete in a 2,000-pound compressive strength mix. Based on the current code, you don't see that that's an allowed compressive strength mix any longer. So the first designation that you'll see in one of the charts right off is that 2,500 psi, pounds per square inch, is the minimum allowed compressive strength for concrete as we're using it, whether in a footing or foundation application. And then typically the cement or concrete that we're using, usually in a driveway, sidewalk, what we call flat work application, typically you're going to see a 3,000 pound application. And as you look at the chart that's in the book, you'll see that we have negligible weathering, moderate, and severe weathering potentials for different applications, and based on that, the concrete mix might require a higher strength and also some admixture to the concrete to help it resist any of those exposures. So without going into a lot of detail, some of the other things that we can do with concrete is we can put different components into it, different admixtures that'll give us different characteristics and different situations. We'll put those admixtures to help facilitate in pouring or finishing or in weathering, whatever the application might be. So I'm not going to go into that. I believe there's other classes that talk more in depth and detail about concrete, but I just wanted to expose you to that basic information about concrete. The next thing that I want to talk a little bit about is in relation to concrete is where we put concrete. Typically on a building site, we're going to do a dig out, remove the surface layer of material, usually it's an organic, grass, shrubs, whatever it might be, down to a firm soil base, and that can be a clay, a sandy loam, or a mixture of those, aggregate possibly. And those surfaces then have a certain load-bearing capability as well. Just like concrete does, the dirt underneath also has to have certain load-bearing requirements. And if you look in the book, there's going to be a chart. It's going to break down different load-bearing substructures. If you have a hard rock base, you're going to have a very high load-bearing capability. If you have a sandy, loamy soil, it's going to be a lower load-bearing capability. Now, years ago when I was building, and if you look at the chart in the book, it's going to be table R 401.4.1. You'll see different load-bearing capabilities, but when I was building years ago, we used a rule of thumb of 1,500 pounds per square foot of soil. And if you look in the chart, that's actually the lowest load-bearing capability, but that gave us a starting point so that wherever we actually were building, we knew that basically we had that minimum load-bearing capability. And so anytime you're working with the design of a structure, and this kind of kicks back to Chapter 3 if you're in the design phase of a structure. Let's say you have a two-story home, you've got some type of either a hand cut or a trussed roof. You've got load from the roof into the second floor, either on the exterior walls or interior walls. That then has to be transferred down through into the first floor via the floor joist system, point loading, whatever it might be, down into the first floor joist system or point loads into the foundation, and then from that point down into the ground. And so you need to know a little bit about why we have spread footings, the reason that we might have larger spread footings. Typically, if you look at a plan that has any type of point loading, you'll have a spread footing or an increased size footing to bear that load on that dirt surface or on that clay surface. And so knowing the soils that you're working with is an important part of any building structure. So I just want to point that out. Based on that 1,500 pounds per square foot number, if you do have a point load or a distributed load based on a footing, you can calculate pretty easily what that load is on that surface and determine if whether or not the footing size is going to sit on that sandy loam or clay or whatever it might be and withstand that load. Sometimes in some situations, inspectors will require that you have soil testing done. In years past when I was building, that happened to me. One time I had to have an engineer come out and evaluate the soils for me. And it's based on the inspector or the building official whether or not he knows the soil in the area that you're building and whether he's comfortable with what your plan requires on that surface. So you might take that into consideration as well. Remember that anytime you start building, sometimes you might have a delay based on inspection requirements from your jurisdiction. The next thing that I wanted to talk about a little bit was rebar. Rebar is a material that we add into the concrete to increase strength and to help the structure of the foundation work properly. Most rebar is sized with a number. So a number 4 bar is going to be 1/2 inch, a number 5 bar is going to be 5/8, a number 6 bar is 3/4. You can have a number 3 bar, which is, I believe, going to be 3/8, and below that you have varying sizes, what they call pencil rod, different sizes based on what the application is. Also, rebar is graded. You can have a grade 60 or a grade 80, and that's going to tell you some tensile strength that goes along with that rebar. Now, most applications that you're going to see in the residential sector is either a number 4 bar 1/2 inch or a number 5 bar 5/8, and those are pretty much the most common bar sizes that you see specified. And then usually a grade, either a grade 60 or a grade 80, that's going to go along with that. Now, as you read through the chapter, you'll find another table that's going to show you some of that information. You can read through and see what that's talking about as well. One of the last things that I'd like to mention, footing sizes and wall sizes. Rule of thumb, as you read through this chapter, you're going to find out that typically on a single-story home, or just say a ranch plan, where you've got just a single level, and this has been from years ago, it's basically the same now, that typically on a single-story home, you're going to have a 6-inch foundation that's going to be on top of a 12-inch wide by 6-inch thick footing. Now, those can be a 2-pour system, it can be a monolithic system, but that's the basic size that you see for typical ranch or 1-story homes. So just keep that in mind. So if you do any design work, that's kind of the rule of thumb, the standard. And then for any 2-story home, typically what you're going to see is an 8-inch foundation wall in thickness, and the footing is going to be 15 inches wide and 7 inches thick. And those sizes have been around for years and years, and typically if you're doing any design work or working with a single story or 2-story, those are going to be the footing and foundation sizes that you'll see predominantly. Unless there's some engineering or some other design consideration, those are the sizes that you'll see. So I just want to point that out. Let's see if there's anything else I wanted to discuss here. Just looking through my notes. As you read through the chapter and as you go through the worksheet that you have, there will actually be some other questions that will require you to dig out the information from this chapter. I'm actually not going to cover anything else at this point. I think as you read the chapter and go through the worksheet, you'll find some of the answers as the worksheet is asking for it. And part of the presentation of these clips is to help you give you a little bit of my perspective as you dig into this information. You know, I probably couldn't discuss everything out of the chapter. It'd make these clips probably a little too long, but anyway, I want to thank you again this week, class, for watching the clip, and you know, if you have any questions, be sure to let me know, either via email or via the online format. Have a good week, and I believe next week is our midterm, so that's coming right up. And have a good week, and we'll talk to you later.